Hi, I'm Jay from RS Garage. Today we're at Mazworx talking about what it takes to properly install a set of billet main caps. So I've got a set of our caps here along with a core block that's going to turn into an RSG 1600, and we're going to take you through all the steps that it properly takes to fit a set of caps. Taking a look at the Toyota 2JZ, we have our main tunnel here. In this area here, we're going to call our main saddles. So you have the pad of the saddle, this flat area, and then you have registers on each side of the main that are going to hold the cap from moving left to right in the block. So the first step we're going to take is making sure that these pads are completely flat and true and clean and ready to receive our new main cap. Now when you true up the pads of the main saddles, again you have 7 individual main saddles here, and the height difference between this one and this one and this one and this one could be up to 1.5 thou. So we're not going to cut all of these the same. What we're going to do is ensure that each individual pad is flat and true. And when we go to do the final align hone, that's when we'll make sure that this tunnel is in complete alignment. So we'll allow some variance in the actual pad height and make it up in the hone later in the job. But we want to make sure that these pads are all flat and true. The next step is determining the width of the main cap versus the width of the main saddle. So when I take this cap, it doesn't just fall down into place. There's interference fit, and in this case, it's around 7/1000 of an inch between the side of this register and the side of the register on the engine block. And you want to have some interference fit. If you are using an engine that has been worked heavily, like overstressed and overrun for a period of time, this area can actually relax where the caps will fall off and on the block once you loosen the fasteners. But you want to have some interference fit because that's going to hold that cap in place and help transmit the vibration that's being presented into the cap and the rotating assembly back into the engine block. Now, if the cap is too wide, you grind the sides of the cap, and if the cap is too narrow, you weld up the sides of the cap and then grind them back down to get proper interference fit. Fortunately for us, in the machining processes that are available, these caps don't require much work to get them fitting correctly in the main saddles. With a main stud or any other stud, the idea is to tighten the stud into the block hand tight. So I'm not putting any real force on that. Turn it with my fingertips, it stops, I leave it alone and go to the next step. As I mentioned before, the cap won't fall all the way into place. It's stuck at the top of the side registers, and I'm going to use the hardware to pull it down into place. Next, I'll install our washers with the bottom side of the washer dry. With ARP Ultra Torque Lube on the bottom sides of the nuts, I can spin the nuts onto the studs and I'll start working the cap down into the saddle. Now the block is machined with an angle at the top of the saddle, so you want to pull the cap down in evenly, but there is a cut here to help it kind of find its way. So I'll turn it a little bit, tighten the other side a little bit, and just work the cap down into the saddle evenly before I torque it. In 3 equal steps, I'll torque the caps to 60 foot-pounds. I'll repeat the process for the other 6 main caps, and then we'll be ready to move to the line bore. Whether you're installing a set of our main caps with an ARP 8740 main stud kit or our 625 main stud kit, keep in mind that the machining processes stay the same. The only difference is the 8740 kit will be torqued to 60 foot-pounds, whereas the 625 kit is going to go to 75 foot-pounds. With the caps torqued in place, we can see that the main tunnel side on the cap is slightly smaller than the main tunnel side on the block, and that's presented here in this lip at the parting line. The next step we'll take is to put the block in a line bore and remove material from the cap, not the block, before we prep it for the align hone. With the caps fitted in the registers, the next step is the line bore machine. The line bore machine uses a shaft supported by 3 independent bearings to keep that shaft from deflecting or moving around during cutting, and a cutter is piloted through the main bore. Now, the object of the game is to take off the material from the cap, not so much material off the block. You don't want to be removing material from the block, but you do need to get the material that's in the line bore back to being completely straight and true. It's a long engine and things do move around a bit during operation. So you're gonna have a different size and different position main bore in the center than on the ends, just because the nature of operation. The crank's moving in the engine, the casting's moving around. There's a certain amount of movement present. And the line bore is an opportunity to get all that straightened out and true while fitting your new main caps. Small amounts of material will be removed from the main cap as the cutter is passed through the main tunnel. And again, you're going to take hopefully less than 1/1000th off of the block side of the main journal. Reason being is if you go hogging material out of that main journal, you're going to be moving the crank position in the engine, which then can create oil pump alignment issues. Now that you're armed with the information of how the line bore works, you understand that no, you cannot put main caps on at home. You must line bore the block. Once the line bore is completed, before the block goes into the line hone for final honing, you're going to check the thrust. So the thrust surfaces, as far as the width of the thrust in the block and the width of the thrust on the cap, is correct. However, the cap is going to sit down in that register and there may be a certain amount of off location left or right. So then you true the space of the thrust to make sure that the thrust bearings are free to float. Thrust placement and bearing placement is critical to avoid crank walk. This is probably one of the most involved processes that you have to get right, and this is why it needs to go to an experienced machine shop. This machine is not an advanced machine. It takes an advanced operator to have the right outcome. With the align bore process completed, it's time to move into the align hone. This isn't a very complicated machine, but the work here is critical. There's a mandrel with stones on it that extend the length of the mains. And that mandrel is going to be passed through the main bore of the engine, and you're going to hone it up the size. So when it comes out of the align bore, it's around 1/1000th of an inch undersized, and you're going to use this mandrel to slowly hone the engine up the size. Now, the size of the main bore has a tolerance. There's a low side of the tolerance and a high side of the tolerance. And what that tolerance is going to do is it's going to keep the bearings in place. The bearings are held in place by the crush of the upper bearing and the lower bearing being forced together by the main cap. The bearing tangs don't have the bearing in place. It's the crush of the bearing in the main housing bore. So it's critically important that that housing bore is the right size. If the housing bore is small, the bearings can buckle. And if the housing bore is big, the heat can't accurately be exhausted through the back of the bearings into the block because there's heat presented at the bearing face. And that's one of the reasons why you're moving through the oil to manage those temperatures and lubricate those moving parts. But this is all critically important to a successful engine build. And the 2JZ being a long engine, it gets a little tricky. And those of you that have some experience with this type of machine, you'll say, well, why is the block mounted right side up instead of upside down? Because there's a cavity in the machine for the block to sit down in the machine. However, the mandrel has a weight to it. And the weight of the mandrel can affect where the material is removed because that weight is going to be preloading one side of the block or the other. And even though this is a cast iron block, we'd rather have the weight of the mandrel down on those steel main caps rather than in the cast iron of the block. With an aluminum block, it's quite more sensitive, and you would want to align hone an aluminum block top side up. That way the weight of the mandrel isn't digging through that aluminum faster than it's digging through the steel on the caps. As that hone is passed through the block and you're removing that last thousandth of an inch, you're bringing that engine into that size, into that tolerance. Now, the size of the main tunnel will influence the bearing clearance. So there are guys that will shoot for the low limit of the tolerance, and there's guys that will shoot to the high limit of the tolerance, and there's guys that will shoot to the mid limit of the tolerance. And it's a mix of the crankshaft sizing, the bearing thickness, and the main tunnel thickness that'll determine the final vertical oil clearance of the engine. But it is a bit of a dance, and it's better left to someone that has experience with it. And this is why you can't just buy main caps and put them on in your driveway. If you're not changing the main caps and you're just changing to an ARP main stud, you're going to be changing that main tunnel size also. And at a minimum, the aligned hone needs to be checked. Most of the time, if you have a used block, the center mains are going to be slightly larger than the outer mains, and you're going to have to align bore that engine to fit an aftermarket fastener because of the additional clamp flow that's presented by the studs. So even if you're just going to swap hardware, you need to have the align hone checked. If there's a takeaway to this video, it's the importance of having a healthy relationship and correct tolerances in that main tunnel of the engine block. If it's not right, the engine's not going to live. You're going to have an oil filter packed full of bearings, and you have to start all over again. So this work is left for someone that has a lot of experience and success, preferably in long engines like the 2JZ. If you're shopping for main hardware or main caps or a package of both, feel free to reach out. Thanks, and we'll see you next time.